Hello, so in today's lesson, we're going to do an intro to linear functions. Um, so our exact learning targets are, I can identify linear functions, I can find the x and y intercepts of linear functions, and I can graph linear functions using the x and y intercept. So, so far, we've been working mainly in one variable. So we've had equations like 5x plus 3 is equal to 13, for example. And we'd solve these, we'd subtract 3 from each side, and we'd get 5x is equal to 10, and we'd get x equals 2. So if you notice, if we graph these, the solutions to these equations, or we've mainly been doing inequalities so far, we are plotting our answers on a one-dimensional number line. So all we have is an x-axis. So these skills are really useful for us, and we're going to keep using them throughout the whole year. But in order to go further into math and model many more real-world situations, it's really useful for us to use two variables. So what the world looks like in two variables would be, we'd have a y variable, and we would also have an x variable. And we'd graph these on what's called the two-dimensional coordinate plane, where we have both an x and a y-axis. So now we're working in two dimensions, both x and y. We're going to be dealing with solving these equations, graphing them, and just learning all about them. So let's jump into it. So a linear function is any function that can be put into the form f of x is equal to mx plus b. Or if you prefer, we could write y is equal to mx plus b. So in this equation, y is our dependent variable. X would be our independent variable. B would be what's called our y-intercept. And m would be our slope. So for now, we're going to delve a lot deeper into these concepts in later lessons. But for now, the important takeaway about linear functions is that they'll have an x and a y in them, but the y, neither of the variables are squared. We don't have any square roots. We don't have 1 over x. We don't have x to the 15th. We don't have 5 to the x. So all of these would be non-linear functions. Anything like f of x is equal to x to the 5th minus square root of x. F of x is equal to 2 to the x minus 14. So these all we're going to explore later. These are not linear functions. So linear functions would again be like y is equal to negative 2x plus 6. We could have 3x minus 5y plus 6 is equal to 14. Those are all just examples of linear functions. So I'm going to erase this real quick. So in order to identify linear functions, we just look for, again, those equations that can be put into slope-intercept form, the form y equals mx plus b. For example, if we have like 2x minus 6x is equal to 42, in order to put this into that form, we could add 6 to each side, or this should be a y, or I want this to be a y. So we could subtract 2x from each side. We get negative 6y is equal to negative 2x plus 42. Then we could divide each side by negative 6, and we'd get y is equal to 1/3 x minus 7, which we see is in that y is equal to mx plus b form. So the graph of a linear equation is a line and so a line plotted is going to look something like this. And today the main concept that we're going to explore are the x and the y intercepts. So the y-intercept is the it's the point where the graph crosses the y-axis. And in parentheses we can say this is the point where x is equal to 0. And you notice, so on our graph we have our x values on the horizontal axis, our y values on the vertical axis, and we can tick off a couple points here. And you notice x here is equal to 3, 2, 1, 0. X is equal to 0 is the equation for that y-intercept. So it can be kind of tricky to remember because the y-intercept is the point where x is equal to 0. But if you look at a graph, it makes sense because, again, we see y could be any value, but x has to be 0 for this y-intercept. Similarly, the x-intercept is the point where the graph crosses the x-axis. And you can see it on the graph here, and that would be the point where y is equal to 0. Because you see, x could be equal to anything, but y has to be equal to 0 at this point. So let's do a couple examples of graphic examples. So suppose we have a function that looks like this. So in order to find the y-intercept from a graph, we just look at, okay, what's the point where it's crossing the y-axis? So the y-intercept would be equal to 1. The x-intercept is the point where it crosses the x-axis. So you see our x-intercept is going to be equal to negative 3. So let's do another example. What if we have a graph that looks like this? So our y-intercept, we just would look at our graph. You see it's crossing, once again our y-intercept is actually equal to 1. Our x-intercept this time, it's in between 0 and 1, so our x-intercept is x is equal to 1/2. So that is how you find the x and the y-intercepts graphically. So algebraically, we would want to use the second definition. So suppose we're given an equation, 2x plus 4y is equal to 16. So in order to find the x-intercept, we're going to set y equal to 0. So we get 2x plus 4 times 0 is equal to 16. So we just get 2x is equal to 16. Divide each side by 2. And we get x is equal to 8. So x is equal to 8 would be our x-intercept. Our y-intercept, we would set x equal to 0. So we would get 2 times 0 plus 4y is equal to 16. We get 4y is equal to 16. And our y-intercept would be equal to 4. So as you can see, once we set one of our variables equal to 0, it's just like solving a single variable equation, which we've had a lot of practice on that by now. So let's do one more example. What if we have y is equal to negative 1/3 x minus 5. So this time our y-intercept is really easy to find when we're in slope-intercept form. So we can just say y is equal to negative 1/3 times 0 minus 5, which is just equal to negative 5. So that's really simple. The x-intercept is going to be a little bit more tricky. It's going to be 0 is equal to negative 1/3 x minus 5. So we'll have to add 1/3 x to each side. We get 1/3 x equal to negative 5. Multiply each side by 3. And we get x is equal to negative 15. So that would be our x-intercept. So that is how you find x and y intercepts, both graphically and algebraically. So we're going to move on now. There we go. Doing a little bit of graphing. So one really nice thing about linear equations, or lines, is that they are, so linear equations are defined by 2 points. So what this means is that all we need to do is plot 2 points and we can graph the linear equation. So I'm going to make a graph here. So suppose a question we could be asked would be graph a line through the points, let's say negative 4, 2, and 6, negative 1. So all we have to do to graph a line through those points is plot both of those points and then just draw a line through it. So just a refresher on our coordinate point notation would be our x coordinate is here and our y coordinate is second. So if x is equal to negative 4, that means we're going to go left 4 units. If our y coordinate is 2, that means we're going to go up 2 units. So we get our first point would be over here. For our second coordinate, if x is positive 6, we go 1, 2, 3, 4, 5, 6. If y is negative 1, we go down 1. And then if we want to graph this line, just draw a straight line through both of those points. And voila, we have our graph. So if we want to do another example, suppose we have the graph through well, let's do -3, -5, and 4, 1. So plotting this point, go left 3, down 5. 1, 2, 3, 1, 2, 4, 5. We got our first point. And for our next point, we're going to go right 4, 1, 2, 3, 4. Just up 1. We would again just connect the dots with a straight line. So those are two examples of graphing a line that are through 2 points. So this is really useful to us because now if we're given an equation for a line, suppose we have, let's do 5x minus y is equal to 15. All we need to do if we want to graph this line is find 2 points that are on this line and graph them and then draw a straight line through them. So 2 points that are really easy to find are the x and the y-intercept. So let's try that. So our y-intercept, we would once again set x equal to 0. So we get 5 times 0 minus y is equal to 15. We get negative y is equal to 15. So y is equal to negative 15. For our x-intercept, we would set y equal to 0, so we get 5x minus 0 is equal to 15. 5x is equal to 15, or x is equal to 3. So now if we graph this, we know that our y-intercept is equal to negative 15. So I'm going to have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sorry. Mix those ones up. And our x-intercept is equal to 3. So we could just plot each of those points. Because our x-intercept is going to be 3, 0. Our y-intercept is going to be 0, negative 15. And we can just connect those dots. And we have a graph of our function. If we want to do one more